See Lindelof videos, solving logarithmic equations, number 7. So here's the first one. We're supposed to solve negative 10 plus log base 3 of n plus 3 equal to negative 10. Remember, what we're trying to get to here is we're trying to solve this. Trying to solve this mess right here. So anything that's not that, we should try to get rid of, just like you would in algebra. So first thing I'm going to do is anything that's added or subtracted to this, I'm going to get rid of that. Can everybody see that? So first thing I'm going to do is this. See, we have a negative 10 here, so I'm just going to add 10 to both sides. And the reason I'm adding 10 to both sides is because I want to get rid of this 10. And to do good algebra, I have to, whatever I do to one side, I have to do to the other, which makes it kind of weird, doesn't it? Because we end up with log base 3 of n plus 3 is equal to 0. So far, so far? So far, so far. From here, and if you get to a logarithmic equation you're trying to solve, and there's not a log on both sides, start thinking exponentiate. To exponentiate is to take something out of logarithmic form by performing the exponent. And remember that this number right here is the base, isn't it? And if we exponentiate, this is the base, and this becomes its exponent, doesn't it? It goes like this, right? It's that circle thing, right? So we'll get we get 3 to the 0 power over here. 3 to the 0 power is equal to our n plus 3. So far, so far? So far. Now evaluate 3 to the 0 power, which of course is 1. You have to always be thinking that with exponential and logarithmic functions, because it's one of the little tricks that's often used in logarithmic and exponential functions. From here, if you notice, there's only a positive 1 in front of this quantity, isn't there? So if you want, you can pretend you multiplied the positive 1 through here, or you can just drop the parentheses. Just be careful. If there was a negative sign, it would be different, wouldn't it? Okay, so I'm going to go ahead and drop these parentheses, but that's why I can drop them. Now what? Subtract 3 from both sides, so we get n is equal to negative 2. Right? So here's our answer, n is equal to negative 2. So you say, well, why is that true? I go back up here, look, put my negative 2 in here. We said that n is negative 2. Put the negative 2 in. Negative 2 plus 3 is 1. What is log base 3 of 1? 3 to what power is 1? 0. So this thing evaluates out to 0, isn't it? So it says that negative 10 plus 0 equals negative 10, which is true. Everybody good? Similar problem would be this one. Negative 6 log base 3 of x minus 3 equals negative 24. Here, this is exactly the same thing. Trying to get to just this part, right? But there's this negative 6 here. How is the negative 6 attached to the log base 3? Through multiplication, so we're going to divide it out. Negative 6, negative 6. Negative 6 over negative 6 is 1. 1 times log base 3 of x minus 3 is, well, log base 3 of x minus 3 is equal to, is that 4? Right, 4, thank you. Is 4. Now what? Now exponentiate. So I'm going to take, remember that this is our base right here, and this is its exponent. So I'm going to take this to this power, set equal to this. So 3 to the 4th power is here, is equal to our x minus 3. There's nothing in front of the x minus 3. There's a positive 1, so I can drop the parentheses, Nolan, right? 3 to the 4th power is 81, yes? X equals 84. And check it the same way. All good? All right. If you have any questions or comments, please let me know. And if you haven't already subscribed, Will said please subscribe. Thanks, Will.